Now, sometimes you need to do it from scratch using derivatives, and sometimes you are able to use compound functions. Generally, or the standard functions. Generally, the standard functions ones are these ones on your formula sheet here. So the e to the x, the ln 1 plus x, the sine x, cos x, arc tan x. Notice that the ln 1 is 1 plus x, which is necessary for this because I think, well, I know if you'd had f of x is ln x, you can't evaluate it at 0. Okay, so ln of 0 is undefined. So that's why we do ln 1 plus x instead. You can get series expansion for ln x just using a different method. We'll just stick with ln plus x. So this is a similar example to what we did to start off with. So find the Maclaurin series of sine 3x up to the x to the 5 term. We're not going to do this from scratch. We're going to do this using the standard formula. So on the formula sheet, you get given that sine x is equal to this. So all I need to do is replace 3x in that formula. So replace x with 3x. 3x cubed over 3 factorial plus 3x to the 5 over 5 factorial plus blah, blah, blah. We will evaluate these terms. This is 3x. That's 9 over 2x cubed. And this is 81. 91 over 40. Yeah, 81 over 40x to the 5. Okay, so something like that is easy enough to just substitute. Now, example 2, you've got to be a little bit careful of. So remember, the standard formula you've got in your formula sheet is for ln 1 plus x. This is ln 3 plus x. Now, what it's tempting to do for this, and please don't copy this down. I'm going to show you a wrong way to do this first. So what it's tempting to do is to write this as ln 1 plus 2 plus x. Okay, which obviously that is the same as 3 plus x. And then substitute 2 plus x into your standard Maclaurin series instead. Okay. So I would be, if I was doing this wrong, I would be replacing x with 2 plus x. So I'd get that equals 2 plus x. And then it's minus x squared over 2. And then plus x cubed over 3. And so on. I've got a bracket squared. What are you going to do with it? Expand it out. It's got an x term in it. Expand this out. It's got an x term in it. Expand the bracket to the far out. It's got an x term in it. You're going to get x terms from every single bracket that you expand out. You're going to have infinitely many brackets. So you're never actually going to end up with the actual x term in this case. Okay, so that's the problem with doing it this way. So we can't do it this way. So instead, I want to make this 1 at the front still to be able to use the standard formula. I'm going to do it like this. I'm going to factorize the 3 out. Just like you kind of do with the binomial expansion, you know, when you make it 1 in the front of the bracket so you can use the formula. I'm going to factorize that 3 out. I can use a log law to split this up. So ln 3 plus ln 1 plus x plus 3, x over 3, sorry. And now that's in a form that I can use the standard formula for. Now I can just swap x plus 3 instead of x, x over 3 instead of x, and that's fine because I wouldn't be like expand it out and get an x terms and x squared terms and stuff. So keep the ln 3 at the front, then write down the standard formula for ln 1 plus x, but put x over 3 in instead. So that's x over 3 instead of x. Minus x over 3 squared over 2 plus x over 3 cubed over 3 and so on. So that's up to the x cubed term. And so I get ln 3 plus x over 3. Sorting this out, So that's minus x squared over 18, and then this one plus x cubed over 18. Okay, so that's just one to be a little bit careful of. So you have to factorize out the number rather than writing it as 1 plus an extra thing. Finally, we're going to do the Maclaurin series of tan x up to the x cubed term. Now, obviously, you could do tan x by differentiating it. It's going to get difficult because obviously you differentiate tan, you get x squared, differentiate x squared. Get more difficult. You can use standard results for this, but it is a bit more difficult. Okay, so obviously you're using that tan is sine over cos. You can't just divide these like polynomials. You just that doesn't get you a power series. A power series over a power series, which isn't a power series. So what we're going to do for this one is tan x equals sine x over cos x. I'm going to bring that cos x up to the top. So we've got the standard formula for sine x, which is on the formula sheet. So standard formula for sine x is x minus x cubed over 3 factorial plus x to the 5 factorial. And standard formula for cos x is 1 minus x squared over 2 factorial plus x to the 4 factorial plus. Now we're only looking for tan up to the x cubed term. Okay. So actually, I'm not bothered about this x to the 5 term. Now, obviously, you need a way to deal with that bracket to the power minus 1. And what I'm going to do on that is I'm going to do binomial expansion on that. You could do, like, Maclaurin series is essentially, like, you could come up with the binomial expansion formula from the Maclaurin series. That's why there's the factorials in both of them. But I'm going to do the binomial expansion on this. And I'm only going to be interested in the x squared term because, again, I'm only going up to the x cubed term in my expansion. Okay. So we've got x minus x cubed over 3 factorial plus blah, blah, blah. And I'm doing the binomial expansion on 1 minus x squared over 2 to the minus 1. Okay, so you can quote the binomial expansion formula, which is on your formula sheet. Formulas here, so you can just quote that. So instead of x, you've got minus x squared over 2. This is 1 plus n is minus 1 minus x squared over 2. And I'm going to stop there because then this would take me up to an x to the 4 term, which I'm not interested in. So I'm going to go up to x cubed. So I'm expanding out now. So x minus x cubed over 6 and 1 plus x squared over 2. Plus dot dot dots that we're not interested in. And now I just do this expansion and just keep all the terms that are x cubed and below. So we've got x times 1 plus x times x squared over 2, so x cubed over 2. And then I'm going to do minus x cubed over 6, and then that's it. Because x cubed times x squared is x to the 5, that's too big. And just tidy this up, so that will give me x plus x cubed over 3. If you do your half minus 6. And that's your expansion for tan up to your x cubed term. Usually for tan, you can differentiate, but it's just tan. Okay. So basically, for doing using standard functions, you're looking for the ones that are on your list. You're looking for e, you're looking for ln, you're looking for sine and cos and arc tan, not tan, and then just subbing things into there. Otherwise, you can do them from scratch. I mean, you can do most of them from scratch, but it will save you a lot more time if you can use standard.